Going to continue our naming journey today. And the first thing that we're going to talk about is unsaturated hydrocarbons. So not all carbons have four single bonds. So if I look at like ethane, okay, each of the carbons has four single bonds to it, okay? If I look at something, the same thing, but with a double bond, now each carbon can only have two hydrogens going to it, okay? So this compound is no longer saturated with hydrogens. It could hold more hydrogens. It could be holding two more hydrogens. So this is an unsaturated hydrocarbon, okay? This is an example of an alkene, a hydrocarbon that contains double covalent bonds, okay? We'll do triple covalent bonds as well, but this one is double covalent bonds. So naming alkenes, very similar to what we did before. Name the parent hydrocarbon. The only thing here is this is a little different. It's the longest continuing chain that contains the double bond. Okay, now that's important for this one because when I look at this one, the longest chain would be 1, 2, 3, 4, 5, 6, 7, 8. 8. However, this side does not contain this double bond, so we're not going to do it. Okay, so we're going to do, we can number these. It's 1, 2, 3, 4, 5, 6. And I'll just go to this one. So we could number that way, we could number it this way. But either way, this is a heptene, except for there are two. So we're going to use this here, hepta. So hept, and then the prefix telling us how many, the Greek prefix telling us how many double bonds we have. So this is a heptadiene. Okay, heptadiene. So hepta meaning 7 in our chain, and then it's a diene, 2 double bonds. Okay, if it was 1 double bond, it would be heptene. This one is heptadiene. Okay, versus heptene. So this is 1 double bond. This is 2 double bonds. Okay. Now we can figure out our alkyl groups. Okay, we also have this group, which is 1, 2, 3 carbons long, so that's a propyl. And then we have our methyl. Okay, so we've got a methyl, we've got a propyl. Those are going to need to go in alphabetical order, so the methyl is going to come first. Okay, then we need to number carbons and parent hydrocarbons. The first carbon atom in the double bond should have the lowest number. Okay, first carbon atom in the double bond should have the lowest number. So if I look at this one, so here's a double bond, and if I name it with blue, I can get this carbon to have a carbon of 1 in the double bond. Okay, if I go the other direction and I use the green, I can get this double bond to have the first carbon as a 2. 1 is a lower number, so we're going to end up using the blue and not the green. Okay, and again, ties will go for the numbering that gives the alkyl groups the lowest numbers. And if that's still a tie, which is super unlikely, then you go alphabetical based on the alkyl groups. Okay? So, based on my numbering, I'm going to use the blues. So this is 6-methyl. Sorry, I'm going to use the blue. So this is a 6-methyl, and this is a 5-propyl. Okay. Now, the thing that's a little tricky here is that we also have to indicate the positions of our double bonds. Okay, and the double bond position numbers go immediately before the name of the parent hydrocarbons, and they're just named based on the first carbon in the double bond. Okay, so as I look at this one, my first double bond starts at carbon 1, so this is a 1, and then the next one comes over here at 5, right? So it's a 1,5 heptadiene. So now I can kind of put everything together. So we're going to start with our 6 methyl because alphabetical goes first. 5 propyl. 1,5 heptadiene. Okay, 6 methyl, 5 propyl, 1,5 heptadiene. All right, why don't you give these 2 a shot and see if you can do them both? All right, so this first one is symmetrical. So if I number it either way, it's a butene, okay? And it's only got 1. And either way, the numbering is the same. So if we go with green, it would be 2-butene. If we go with blue, it'll be 2-butene. So this is 2-butene. Okay, now this one's a little bit different. So we can pretty clearly see that we need to number it this way. Okay, so this is once again a heptene, but this time it's a heptatriene. Okay, I'm just going to move this over a little bit. Okay, and the numbering for the heptatriene is going to go 1, 3, 5 heptatriene. I also have this methyl group here, and that's my only alkyl substituent. So that one is a 4-methyl 1,3,5 heptatriene. Okay, dry condensed structures and line structures for 5-methyl 1-heptene. Okay, so I know it's a heptene, so I can do my carbon backbone first. And then I can fill in my heptene, so my double bond goes here. Okay, and then my 5-methyl, so 1, 2, 3, 4, 5. There's my 5-methyl. Okay, there's my condensed structure. Also with the lines, 3, 4, 5, 6, 7. Okay, so there's 7. Put my double bond at 1, 1, 2, 3, 4, 5. There goes my methyl group. Okay, so there's my line structure. Oh, I guess I don't want to do that. No, that's not going to work. Okay, 2,4-hexadiene. So that's 6 carbon backbone. 1, 2, 3, 4, 5, 6. And it's a 2,4. So 1, 2. There's a double bond. 3, 4. There's another double bond. And this one's nice because it's symmetrical, so it's actually the same both ways. So CH3, CH, CH. You just need to be careful about how many connections you have to each carbon, right? CH and then CH3. Or 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And then the last one, 2-methyl-3-heptene. So once again, a 7-carbon chain. One, 2, 3, 4, 5, 6. I can count, and that's awesome. There's 7. Okay, I'm going to put in my 3-heptene. 1, 2, 3. So there's my double bond. There's my methyl group. And then I can fill in. H, 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 H2, H2, H3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 2-methyl, 3-heptene. Okay? Now, for the next part, this is where it gets a little bit weird. Okay? If I ask you to name these structures, okay? So for this one, this first one, or actually, why don't you give this a shot? So this is 1, 2, 3. So that's a 2-methyl 1, which is not really necessary in this case. Okay, it's a little bit redundant because protein is always, or propene, not propane, propene, Mr. Ryan. Propene is always going to be 1 propene, right? Like there's no other way to do it. Okay, now these two, when I look at them, they both, the longest chain now goes through them. So they both look like 2-butene. Okay, when I look at the chemical formulas for all of these, so this one is C4H8. This one is C4H8. And this one is C4H8. So this is isomers. So this first one has a different connection along the backbone, right? It's got a different backbone. It's very, very much a different molecule. And this one is called a structural isomer to the other two. Okay, so let's talk about these other two. Okay, if you've talked about hybridization, okay, we know that this one is an sp2 hybrid carbon, this one is an sp2 hybrid carbon, and this one is an sp3 hybrid carbon, same with this one down here. Okay, so and same kind of thing here, sp2, sp2. If you haven't had hybridization, that's okay. It's not the big deal. You just kind of have to remember this rather than kind of understanding it. So you'll remember with the sp2 hybrids, you kind of have these sp hybrid orbitals, and then you have these p orbitals, those leftover p orbitals, left over which makes your pi bond for your double bond, okay? Now, the deal with this is that these structures, the reason that this is important is that this pi bond can't be broken. Like you can't change the orientation of that pi bond, which means that you cannot rotate this compound about this axis, okay? Which is what you would need to do in order to be able to say that these two are the same compound. So they're not. So a single bond has free rotation, so that CH3 can rotate in all different directions. It's totally fine. But the double bond and a triple bond also cannot rotate because of these pi bonds. Okay, so these are actually, these other two are actually different molecules. Okay, they are isomers to each other, but they have the same connection, right? They're both 2-butene. These are what's called geometric isomers. Okay, so geometric isomers. Geometric isomers happen anytime that you have a double bond, and the way that they're named is based on the orientation of the large groups. Okay, so I'm gonna put like heavy green lines on the large groups. So in this first one, if I draw a line down the middle of the double bond, okay, these two heavy substituents are on the same side. Now, one of them's, in this case, they're both methyls, but if one of them's like a methyl and the other one's a propyl, it doesn't really matter, okay? You just do the heavier ones, okay? So if the groups are on the same side, we use the word cis, okay? So this would be cis 2-butene. If the groups are on the opposite sides from each other, we call these trans. Now, you'll notice that I said we use the heavy groups, but notice that if you use the hydrogens, it ends up the same as well, okay? So this one is trans 2-butene. Anytime that you have a double bond, you have to be careful about geometric isomers, okay? You just have to be aware that they are there. Okay, so we've done alkenes, like simple alkenes. We've done branched alkenes. We've talked about geometric isomers. Now let's talk about cycloalkenes. It's exactly the same as the cyclo ones, but now our numbering has to go through the double bond, okay? So we've got two directions that it can go, 1, 2, 3, 4, 5, or the blue, 1, 2, 3, 4, 5, okay? In both of these numbering systems, we go through the double bond first, okay? So you have to give the double bond the lowest number first. Then after that, you give the substituents the lowest number first. So here, it's either going to be in the 3 position, the methyl group's going to be in the 3 position if I use green, or the 5 position if I use blue. So we're going to use the green, okay? So this one would be 3-methyl cyclopent 1-ene. Okay? This just tells us the location of that bond. Okay? So what if I do this one, where I have 2 double bonds and a methyl group? Okay? So numbering could go 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Okay, we have to go through the double bonds first. The double bonds take the priority. So we can't go like 1, 2, 3 because we need to go through the double bonds first. All right, so this one would be 5-methyl cyclohexa 1,3-diene. Okay, 1,3-cyclohexa 1,3-diene. Now, you may well see this one as just 3-methyl cyclopentene because the 1 is kind of assumed, would be kind of assumed in there. But for this one, we need to make sure that we give the location of both of those double bonds. Okay, so that more or less wraps up our discussion on alkenes. Okay, the next thing that we're going to talk about is alkyl halides. So halogens, we've added halogens. And for halogens, we treat them the same way, except for they get the OMO ending. So they just get an O ending. Sorry, O ending. So chloro, fluoro, bromo, iodo. Okay. So if I'm going to name this one, okay, this is a hexane, and the numbering that gives me the lowest branching is this, okay, which means that I've got a fluoro group, I've got a chloro group, and I've got dimethyl. Okay, so now I need to put these in alphabetical order. Okay, so this is going to be, so chloro is going to go first, and chloro is at the 2 position, so is fluoro, and the dimethyls are both 3,3. Okay, so it's going to be 2 chloro, 2 fluoro, 3,3 dimethyl hexane. Okay, why don't you give this one a try? The second one over here. Give it a try. Okay, so number the longest chain first. So it has to go through the double bond first. Doesn't matter which methyl group carbon we go to, both of the numberings end up the same. So this is, my substituents are a 1,1 diiodo, and then the 3, the 2-methyl. Okay, now for this one, there's no cis trans, right? Like if I rotate this about this bond, it's the same molecule. So I don't have to worry about cis and trans, which is nice. So I can just do the naming. And iodine comes before methane, or I comes before M in the alphabet. So it's 1,1 diiodo, 2-methyl, 1 propene. Okay. Let's see about this compound versus this compound. See if you can name both of those. Okay, so this one is 2,3-diiodo cis 2-butene, because the heavy groups this time would be the iodines, and they're on the same side. Now the iodines are on the opposite side. So this is still 2,3-diiodo trans 2-butene. Okay? All right. So that's alkyl halides. Exactly the same. So now the last thing that we're going to talk about is alkynes. Alkynes function exactly the same way as alkenes. So I'm going to number to go through the triple bond first. Okay, so this is 1 bromo, and the bromine is going to come before the methyl. So 1 bromo, 3,3-dimethyl, 1 butene. Okay, with an Y-N-E at the end. Okay, and that's all we're covering for today.